Hi. In this section, we're going to just briefly talk about tree and Venn diagrams and how we can use tree and Venn diagrams for probabilities. And it's just really, we're just like tapping the water. We're not going in or putting our feet in. It's just a quick overview of how these diagrams are related to probabilities. So let's go ahead and start with a tree diagram. So a tree diagram looks like a tree, and we can draw a tree with the leaves up here and down, or we can draw it sideways like a bush, right? Like one little leaf here and then a whole bunch here. And so if we start with tossing a coin twice, we already called that sample space back in example 314, and we said, okay, that either you have two tails, one tail, one heads, heads, or heads first tails, right? So let's draw, this is how we wrote the sample space, but let's actually represent the sample space with the tree diagram. So here, you would start off with a tails or a heads, right? So the one coin has a tails or a heads. And the branch would be next, which would be if I tossed a tails next or a heads next. If I did a heads first, I could have done a tails next or a heads next. Okay. Now, if I flipped it a second time, right, that means that I would either have a tails, sorry, the second time, right? So here's the first toss, I did a tails or a heads. The second toss I can get a tails or a heads on each one, right? So if I did a tails first, I could have a tails next or heads next, right? Which are these first two in the sample space. If I tossed a heads first, then I still have the option of getting a tails or a heads, right? That's the last two in the sample space. But just as a light example, let's look at a third toss. That means I could keep going, right? Because then at this point I would get a tails or a heads. This third toss would be a tails or a heads, tails or a heads, tails or a heads, right? And then I could keep going and going, right? But we only tossed it twice. So again, this was like the first toss. This is the second, and this would be like a faux third toss if I wanted to. And you can see how like big the tree can get at this point. But we look at this and the first and second to find the probability of tossing more than one tail. So more than one tail, that would mean two or three or so on, right? It has to be more. But since we only toss the coin twice, we only have one event, right? So we would just look for that event of tossing it more than once. So here, tails, tails. This would be tails, heads, heads, tails, heads. Nothing more than once. It has to be twice, which would be right there. Tails, tails. And then we would see, well, that only happens once out of the four outcomes in my sample space. So if the heads and tails or the tree diagrams are nice when you have a lot of outcomes and you just want to be able to read it and circle it. Other than that, we would just use the sample space here and calculate probabilities as usual. The Venn diagrams is interesting. John Venn was a great mathematician, and he designed Venn diagrams off of Euler, this other famous mathematician, Euler is one of my favorite mathematicians, and he developed Euler circles when it came to logic and sets. And Venn diagram, or John Venn had developed from the Euler circles the Venn diagram, which simplifies sets in a lot of ways. And so let's go ahead and see what a Venn diagram looks like in an example. So we know that a Venn diagram, because we drew one briefly with the Queen of Hearts, is just like a rectangle with two circles in it. So a survey of 200 people are asked, what beverage do you drink in the morning? and offers tea only, coffee only, or both coffee and tea. Suppose 20 report tea only, 80 report coffee only, and 40 report both tea and coffee. Draw a Venn diagram representing beverages people drink in the morning. How many people drink tea in the morning? How many people drink neither tea nor coffee? So there's a lot going on here. The first thing we want to do is draw the Venn diagram. So let's go ahead and put a rectangle. Okay. And then we'll draw 2 circles. And here we have coffee, tea, and then the rectangle outside we always call like the universal space because we don't want to say everything in the universe. We just want to say coffee and tea and then all drinks maybe or something. You know, this we're only looking at drinks here and we're going to look at little smaller sets. So let's go ahead and put this together. So 20 report drinking tea only, 80 report coffee only, and 40 report drinking both. So 40 goes in that intersection because they drink coffee and tea. Okay, so how many people drink tea in the morning? Well, drinking tea would be this entire circle. And you can see that the 40 and the 20 are both included. So we could see easily that the number of people that drink tea is equal to the number of people in the intersection because they drink coffee as well, but they can drink tea as too, right? Plus 20 and it's 60. So 60 people in the survey drank tea. Whether some drank tea and coffee, but they drink tea. Okay, so the second part would be how many people drink neither tea nor coffee. So now what I'm looking at is, let's do purple, neither tea nor coffee. So I want people to drink maybe orange juice in the morning or Red Bull. So here's coffee and tea, and here's everyone that drinks something else. Right, so that's the number of people that drink neither tea or coffee. Well, how many people were surveyed, right? Well, 200 people were surveyed, right? And of those 200 people, 80 said they drank coffee, 40 said they drank both, and 20 said they drank tea. So that means that 200 minus all those coffee and tea drink people is the number of people that don't drink any of those, right? So we'll do 200 minus the number of people who drink coffee, minus the people who drink both, minus the people who drink tea only. So if we do that, that would mean that you would have 200 minus 80, minus 40, and then minus another 20, which would be 60. So you can see once you do the Venn diagram, it's much easier to read the answer to some of these questions versus like just reading and then trying to think about it in your mind. So the Venn diagram and the tree diagram just give a visual of the probabilities. So they're helpful, it's not required, but it's a nice way of putting them together.